Oh, good.
You got it? Okay. It is time, so we're gonna get started. Thank you everybody for being here again. So I was given orders from Jason. The director search update is there is no update. There you go. In case you weren't here, you'll see it in the newsletter on Monday. Yeah, yeah. Also, I'll plug it again. Internship deadline is Sunday. Yeah. Huh?
Share it.
You shared it on Facebook.
There's
Yeah.
only like 3 shares today. Share it.
Share it. Go to our social media page and share it, please. Anyway, so that's all our announcements. And now it is Steve talking about joints and Kentucky.
Here's what I found.
Sorry, y'all. That was weird.
Thank you, everyone, for coming. Can everyone hear me okay? Good. Today I just wanted to update you on a couple of projects I was working on. Create a joint map for Hardin County and a joint database. I originally thought I would give a talk about arches as I'm trying to get a arch paper published, but thought I'd save that for another seminar. So today we're just going to focus on joints in Kentucky. And this is not about legalization of marijuana in Kentucky. This is about fractured rocks, okay? So outline for the talk, give you a timeline of the data, the joint data that was collected in Kentucky, either by the geologic mappers and myself. I'll present the Hardin County joint map that was just published as our map and chart series. And update you on my next project is Warren County, and also talk about a joint database that I've been working on. Oh, I'm gonna go back. I didn't go anywhere. So this outcrop here, as you can see, this is the Bluegrass Parkway. This is in the Nelsonville Quad. This is mile marker 6, real close before you get to the interstate in E-Town. And you can see right here these systematic joints, one right here, one right here, one right here, all throughout the outcrop here. And so these fractures are in the rocks are what I'm measuring. The timeline for the data collection. Geologic mappers spent 18 years collecting this data. And about 20 years later, we digitized it. It started in '96. I was hired in '98, and for about 5 years as part of the digital mapping. Took a break from that and did superficial mapping. And in 2009, took a break from that and started a joint database. And back in 2009, Richard Smath, when he worked here, we were getting requests from the transportation cabinet for stretches of road that they were thinking about working on. And I would go out and drive the road, and I would measure joints along the area, and we report that to the transportation cabinet. And I also went to a selected other road cuts. The one I just showed you on the Parkway, I measured joints there, and then on the Interstate 75, just south of Berea, there's 4 or 5 nice exposures there. And I also collected I found that the best joints are the ones that are off the road. And so I figured the best place to collect these are at natural arches. So killed two birds with one stone. So I took another break for about 5 or 6 years and did some more superficial mapping. And then during the pandemic, I switched to back to joints and natural arches. Started compiling the DVGQ joint data and the joint data I collected at the natural rock openings. 2022, I started mapping the Hardin County, and then last fall I started mapping in Warren County. So that's the timeline of the work so far. And this is the map that Emily and I just published through our map and chart series. Realize this might not be, printed out on paper, but it's paper-like. And so we have the map of all I've got shown here are the faults, the data I collected, and the data the geologic mappers collected. I omitted the geologic map units from this map so the user can see the data better. Also on here on the caller information, we have an explanation explaining the map symbols, a stratigraphic column along with Rose diagrams showing the orientations of the fractures or the joints in each map unit. And I'm not sure if you can see it, but the N value would be underneath the formation name. Below that, we have a histogram of azimuth orientations and a histogram of dip degrees. You can see most of these are steeply dipping. I'll show this in another slide in a minute. We have a small inset map of the county showing the geologic map units and a couple of photographs. This is the Bluegrass Parkway exposure. And just a couple of examples of inclined joint and a joint set. So this is what the map looks like. The purpose for this geologic map you can use for hydrological purposes, geotechnical purposes, rockfall slope stability and rockfall mitigation, and maybe in certain counties, maybe not Hardin County, mineral exploration. To zoom in a little bit, this is what the explanation looks like. My data that I have collected is represented in the black symbols. The DVGQ data, the published geologic maps, are the blue. Okay, so you can see the different orientations. We have joint sets, we have inclined bedding or inclined dipping, inclined joints, sorry, getting ahead of myself, and joint sets. And the faults are labeled up and down thrown. An example of the type of joints that I've measured. Dipping joints, and like I said, most of them are pretty steep. Vertical joints. Here we have an inclined, a dipping joint, and a vertical joint set. And then right here, this way is another joint set, and then coming in and out of the screen towards me is another vertical joint. So that's the type of joints I'm measuring and how I'm attributing them. The geology of Hardin County. Most of this is located in the Mississippian Plateaus region. Of the northeast corner here is the Knobs. The area is dominated by the St. John and St. Louis, and that's where most of the joint measurements are coming from. Sinkhole and karst topography up here towards Fort Knox, and also here in the southeast. And most of it seems to me a lot of the sinkholes occur in St. Louis. I know also occur in other limestones. Faulting in the western part of the county. These are steep angle normal faults, offshoots of predominantly east-west Rough Creek fault system. And in relation to the strat column over here, you can hopefully better see the N values and the orientations of the joints. The modern day stress field since late Devonian is northeast southwest, and you can see pretty much most of these joints are striking a little bit to the 20 degrees or so to the northeast, and close to 80 degrees to the northeast. So some of it's a little noisy, but I think you can pick up pretty consistent trend here. And so the stresses involved that are going to create these joints are tectonic. And so close to the faults, there are many joints that are parallel or at least subparallel to the faults. You can have joints forming from hydraulic stresses. I'm not exactly sure what that looks like. There are some joints that are filled with calcite, so maybe that's evidence for hydraulic stresses creating the joints. You can have unloading stresses that reflect the ancient stress field. And then you have what's called release joints, and that's more related to the fabric of the deposit. And so if you see right up here in the Big Clifty sandstone, that you get all a range of orientations here. And so maybe, just maybe, this is related to more of a release stresses than unloading or tectonic. But that's just a hypothesis at this moment. So that's what the geology and the strat columns look like in the joint measurements. Orientation of the joints. As you can see here, we get dominant orientations here at 0 to 20 degrees, and another one around 80, 70 degrees. Minor orientations at 50 to 70 degrees to the northwest, and similarly to the northeast. Going pretty quick here. Okay, so how I collected this data. Mostly drove all the roads in Hardin County. So I would walk the outcrop, pick out, see what joints were exposed, and then pick the best joints that I thought were representative of that outcrop. Occasionally, the best, like I said, the best joints are exposed in rocks that are off the trails, a lot of them in stream valleys. And so there were a couple of hiking trails that I could hike to measure, to get some data. And during the dry season last summer, I was able to get on the Nolan River to get some data. So I targeted areas that were not covered by the DVGQ data. Although when I was out in the field, I don't know if I saw one outcrop that the DVGQ data was measured from. So maybe they're all gone or covered over. But we'll get talked about a little bit later. Like I said, I would walk the exposures to identify which joints were available and then collect that data. Used a Brunt and compass the old-fashioned way, and entered the data into the Field Maps app on my phone. The map scale that we printed this out is 1 to 25, the county scale. But I collected this as if I were making a geologic map, so 124,000 scale or greater or less. And is there data bias in here? Yes, there are, because I'm not measuring every single joint. I'm measuring the most pervasive joints that are indicative of what I see at the outcrop. And if I see an orientation change, then I'll record that measurement. And I'm, like I said, going to learn some techniques to remove this bias from my investigations. That was Hardin County. This is update of what I've done so far in Warren County. Mapped the Bowling Green South Quad, exposures in Bristow's and Smith Grove, and working up to this area up here. This is the Dripping Springs Escarpment, and hope to do this part in the coming months before the leaves come out. Here's the geology of the Warren County. Again, most of this is in the Mississippian Plateaus region, in the southern part of the Western Kentucky Coalfield. Here's the Dripping Springs Escarpment. It's pretty well defined here. but it kind of lose that definition as we go west. And most of this area here is again underlain by St. John and St. Louis, and this part here is a sinkhole plain. So most of my data is going to be up here, and maybe late summer I can get into these creeks again and get some data there. Okay, the joint database. Currently, in our joint database, I have DVGQ data and data I've collected at Natural Arches and this Hardin County joint map. I will add data that I collected from the transportation requests and the other selected road cuts. Any other published data that I may come across. I know there's a couple of theses and that I will include. So this data, excuse me, my mouth's getting dry. Plus I want to like stretch this out. We'll be gone here in a few minutes. Make you, all of you came, so you know, make you stay here for a little bit. So this data is available on our map service. It's also available on ArcGIS Online. I've shared this with our organization. I can make this public, but right now it's, you guys can access it if you want it. And on UK Knowledge, I've published the DVGQ joint data, my joint data, and the joint map, all three for UK Knowledge. So the attributes, the data I collect from out in the field, and this took a long time to get this. Before I had a one-to-one relationship in my spreadsheet. Okay, now it's a one-to-many, and it took me a while to get there. A one-to-one was easy. So location table, you know, those attributes that the county, the quadrangle, the XY coordinates, and how confident I am in that location. Measurement table, IDs to, you know, help identify the station, the type of fracture, if it's a joint or if it's a fault. Description, is it dipping? Is it vertical? Is it a vertical set? Map symbol, this is for the user to plot the map symbol in ArcPro. If you look at their gallery, they have incline joints and they have vertical joints. And so the that will be attributed with one of those two choices. Provided the GQ map unit and the DVGQ map unit, the lithology the joint appears in, its orientation and dip. So these will always be filled out in the attribute table. And I have some other attributes here that not all of them will be included at a certain location. The planarity, is it curvilinear or is it planar? Okay. And on a scale from 1 to 4. On a scale from 1 to 10, a surface roughness. Is it smooth is 1, if it's rough, it's 10. Fracture termination. Is it pervasive? Does it cut through the different bedding planes? Or does it terminate with another joint, which would be a budding? Or did you just stand through the bedding, which would be blind ending? So the 3 choices there. Aperture width. If I see evidence of any water or mineralization, I'll make that note of that in the attributes. So this is what the data looks like on our map service. The data is located in 2 places. We have the GQ data, okay, and then other layers will find my data. So this is all with the DVGQ part in our map service, and this is in the other layers. You'll see the other joint symbols. And so something to think about. I think if it would be cool, if I don't know if it's possible, it gets kind of messy to showing the joint symbols at this map scale. but maybe we can make these points, and as we zoom in, we get to a scale of maybe 1 to 48,000 or something like that, then maybe the joint symbol can appear. But because it's really kind of tricky when you're trying to scale these joint symbols and you zoom in and your joint symbol's not moving or getting bigger or smaller as you zoom in. So it's kind of tricky. And here's a zoom in part of our map service. Again, the DVGQ data. It is questionable. I've attributed the location and the measurement as questionable. Okay, like I said, when I was in Hardin County, I don't know if I saw an outcrop that they use for the geologic map. Okay. There's also registration errors when we digitize these maps, which will mess with the location. Uh, uh, we did not have the original field mapper's notes when we digitized the data. I'm confident in my data and my location and my measurements mostly. Sometimes I'm not sure if I'm looking at a joint and I might call that questionable. But so right here I've zoomed in. This is this point right here is a DVGQ joint, and this window here corresponds to that point right there. And you can see how the attributes go. This is a joints measured at a natural arch along the Kentucky River, and it's pretty interesting there. You can see how the drainages sometimes are controlled by the jointing. Okay, so and you know our joint data looks like this too. We have dipping to the north or striking to the north, to the northwest, and also to northeast, and a little bit east-west. So this is how we calculated our structural symbols, or striking, or for bedding, or for joints. We still don't have these. I think they're in a library in Denver, but I don't know how you get there to get those. The DVGQ data was created by digitizing TIFF images of the Mylars, and these Mylars were used to print the paper maps. And like I said, the location and measurements are attributed as questionable because I don't have the data and we're trying to generate it. And so how we would do this is a bedding symbol. You would click here, you would click 2, and then you would click at either end of that symbol to get to the orientation. And that was a script. Did Jason Patton do that, Tom? I think you said. So they hired a bunch of us in 1998 to digitize these maps, and Doug, myself, a guy named Jason Patton, 5 or 6 other people. And so that's how we created or got the strike and dip data for structure symbols, and that's why it's questionable. So this is what the joint database looks like in ArcGIS Online. They don't have any joint symbol capabilities in this platform. You can do it in ArcPro, but not here. I've currently got this shared with KGS, as I mentioned. This is one to many cardinality. And again, it shows us my location table. And then over here, you have a related measurement table and a place here to download images. So I think we can do that, load images for the map service, right, Doug? But I think I have to like physically do that. So that may take me a minute to do that. So, and so that's what it looks like on ArcGIS Online. To get to this data, the second way is the UK knowledge, and on there, like I said, I got the DVGQ data that's separate than the KGS data, and then I have this map data for the Hardin County. So Drew just left, but is awesome of him to let me do this. This is really fun. I enjoy doing this. I like making maps, so I appreciate him giving me this opportunity. Emily did a great job of making my map or making our map look better. Rachel did a great job of making it read better. And Matt Crawford and Mark Carter made the science better. So I appreciate their efforts. For the joint database, Doug was a big help. Devin also was a big help, helping me understand and figure out some of the relational databases and getting that into ARC GIS Online, and then again to the Field Maps app. So they were a big help. And Cheyenne was did help with, of course, getting this to UK Knowledge. And kind of feel like I gave you the conclusions, but I'm really appreciate you hearing. If you have any questions, I'm happy to answer them best I can. Steve.
I was gonna make a comment. We do have some of the USPS field notebooks. Not many. There are some back there. And at one time, we had microfiche in one. And you could print off a microfiche for you. This is showing, for those of you that don't know, this is neat.
Yeah, right.
But that USGS, you could also get copies of the microfiche. To print out the
So for the people online, Steve made the comment about the field notebooks. I've looked at those field notebooks next door, and they didn't have anything on structure. A lot of it was just drill hole data. The microfiche, a lot of that again was drill hole data that I've seen, but I haven't seen anything. Right. And I know they got a big library out in Denver. I asked Mark Carter about it, and I mean, he got busy doing other things. but you know, Carrie.
I would say the odds of us throwing out microfiche that we used to have are very, very slim. They're here somewhere.
Right.
I would imagine. The amount of microfiche Liz and I took out to Earl at one point is crazy. So they could
Well, I
be
use the
stored
micro.
film, they could be in a drawer. There's a
Yeah.
reader out there. If you really feel like getting in the weeds, I bet we still have those microfiche somewhere.
Well, I had a box full of microfiche and the reader in my office when I was doing drill hole data for Western Kentucky.
It's tedious. It's horrible.
Yeah.
It's gonna hurt your eyes.
So, yes.
For the fractures that you measured, some of them were orthogonal. Did you note any age relationships?
No, I didn't. Brendan?
Why, I didn't know visitors were allowed.
Yes. So I don't, anyway, Brendan is visiting us, and some of his employees from Kansas Survey.
Yeah.
Brendan went to school with Doug and I. We had the same thesis advisor and Bob Hatcher, and he's visiting. So yes, you can ask a question, Brendan.
Have you, is there any like wireline data or well logs that you could use to extend into the subsurface, like FMI logs, you know, resistive fractures?
I'm sure there is.
There's some, but we don't have that much. I mean, we as a state don't have that much. So there's a chance there's one nearby, one of this holes, but it's not gonna be a shot in the dark. Certainly not enough to build a database.
But that's something I hadn't thought about. And I didn't really know if it was available. But,
Yes, I was thinking, you know, general dip meter data or something you can extract deeper fracture sets.
right. Well, it'll certainly be more tectonic in nature, or even hydraulic. Hudson?
I was wondering the same thing, like how much can we get these joints deeper into the rocks and away from the outcrops? Specifically thinking of like your Harding County data, because we mapped probably close, a little over 1,000 sinkholes in Harding County using LiDAR. And obviously there's got to be some relationship with these joints and sinkholes probably.
Yeah.
If we get that using this joint data, it would be really interesting.
Yeah. So what was the first comment again?
I just like, what do we, like, how much can the joints
Oh.
on the outcrops propagate inward to the west of the rock?
Right. Yeah, I was out there recently and, I was looking like, I saw it, a nice big joint face. And then it continued into the rock, but it was a lot smaller. And so, when it's exposed, it's going to be exposed to the weathering and it'll expose itself a lot more than when it's, covered and back into the rock face. But there certainly is, a trend with the sinkholes. I mean, the drainages are also trending in a certain direction. So the sinkhole plane out there is just covered.
Yeah.
And so I don't know if you could get an orientation and something.
You could do a limit analysis, but wouldn't really be mapping, it'd be more interpretation. Because, yeah, like they said, when you have a sinkhole, it's flat, so it's being covered, because you can't actually see the fracture, but you can see a bunch of sinkholes that are relevant interpretation, right? So this one through the video.
Well, that's the thing,
How do you prove that?
in the sinkhole plane, I mean, I don't know if you could align them. I mean, they were just kind of everywhere. So, but that wasn't my goal in, lining up, but it just in an observation.
To get a sense of one other source is the caves. There's a lot of fractures.
Right.
In caves.
Right.
And the cave passage itself, like we're talking about, follow a lot of these fracture networks. I think they likely do.
So maybe that's something we can work on for the next map for Warren County.
Yeah, to build out these joints as they continue. Right? That's just interesting to see what their distributions are like as they.
Yeah.
What are the connections they can make?
So it's,
Yeah, just thinking about your Warren County data, Lost River Cave is 6 miles of passage underneath the city, right in the middle of the party.
I'm sorry if I'm not updating the people online. But yeah, I went to Lost River Cave and was able to get some measurements outside the cave, but in there's a little hiking area there, which is really kind of a neat place. So. Yes, Marty?
Steve, Warren County and Hardin County are just pretty close to it, right off the flank of the Cincinnati Arch. Arch has been a positive feature, at least since the early days. Has that exerted any influence on your point orientations?
I'm not sure. I mean, I didn't really think of the Cincinnati Arch affecting these joints. I was more looking more local in the localized faulting and how that may have affected the orientation of the joints. So that's not something I really considered. But I will now. All right. Thank you. Appreciate you coming.
Yeah, I forgot to introduce our Kansas guests. We have Brendan, Olivia, Rachel, and Nikki. Right here, they're visiting from the Kansas survey.
I can hear you well in the back.